Welcome. In this video lecture, we are going to revisit our topic on testing of hypothesis. So we are going to revisit this topic using a case study data, which is a student's performance data. So you can download this data set using this particular link, which is the kaggle.com, or either you can download this data set from our website. Okay, so let me open this one. So if you are going to download this one from the Kaggle, so you are going to find out these set of variables. So these four variables I have created by myself. Okay, so overall performance is calculated based on the average of these three scores. Okay, and the verdict I mean that if the overall score is 40, it is going to be acceptable performance. If it is less than 40, it is going to be not acceptable. Okay, so this subject and score, basically we have rearranged the score. Okay, so I have taken the math score first and written down the subject is math. Similarly, we have written down reading score. Okay, and then corresponding to that we have just copy paste the reading score. Okay, so that is basically the data set we have. Now using this particular data set we want to analyze. So the first hypothesis which we want to check, that the claim is that there is no difference in the mean student performance in any of the basic literacy skills. That means on average students are equally good in reading, writing as well as in mathematics score. Okay, so which means if we are going to talk about in terms of IPO diagram, so right now our critical to quality or the KPI is basically the overall students performance score. So that is our KPI. So our input is basically the factor is the subject. Okay, whereas it has three level. One is reading. Okay, and other is writing, and other one is math. Okay, so we have three levels. So that means if we have one factor having the three level, so in that case what kind of test we can apply? We can apply one way ANOVA. So which means we want to compare three averages, whether all three subjects on average are equal or not. So what would be our null hypothesis? That is going to be the mean of math score is equal to the mean of writing score is equal to the mean of reading score, whereas alternative is going to be at least one of them is different from the others. Okay, one of them is different from others. Okay, so that is going to be our alternative hypothesis. So that is basically the H naught or H1, or we can say HA, right? So in order to check this one, what we can do is, so we are going to apply either we can apply one way ANOVA, or either we can apply the Kruskal-Wallis test. But under what condition we can apply one way ANOVA? If the overall performance, mean the score of these subjects are normally distributed, then we can apply one way ANOVA. But if this score is not normally distributed, then we have to go towards the non-parametric test, which is a Kruskal-Wallis test. Okay, so that means first of all I am going to check the normality of this one, because it is a variable data. So score is a quantitative or a continuous variable. So we are going to start basic statistics normality. Okay, and then I am sending the score variable. Okay, and Anderson-Darling test, press OK. So if you can see that the data do not follow the normal distribution. So if data do not follow the normal distribution, that means we have to pick one of the non-parametric. Either in that particular case, if we have three levels, either we can apply one way ANOVA, or either we can apply Kruskal-Wallis test or a Moore's median test. So we studied that if the data contain most of the outlier value, then we can go for the Moore's median. Otherwise, we can apply the Kruskal-Wallis test. Okay, so let's check, is there any outlier? So we can use box and whisker plot. Okay, that is 1y with groups. Okay, and the graph variable is going to be the score, whereas the categorical variable is going to be the subject. Okay, in a data view I am sending subject. Okay, however, we would be able to get the box and whisker plot in a colored form. Okay, so as we can see that from the box and whisker plot, it seems that students are doing good in reading on average compared to maths. Okay, whereas the reading and writing approximately look like equal. So there are few outlier, but there are not so much outlier. So we can apply both. Let's see what's the results we are getting if we are going to apply Kruskal-Wallis as well as if we are going to apply Moore's median. Okay, normally if there are a lot of outliers, then we can go for the Moore's median. Otherwise, in this particular scenario, because data do not follow the normal distribution, we can apply Kruskal-Wallis test. So stats non-parametric Kruskal-Wallis, the response variable is score, the factor is basically our subject. So press OK. Now, if we can see that the p-value is basically less than 5%, so that means we are going to reject H naught. That means the students' performance in the three subjects are not equal. So at least one of the subjects or performance is different from the others. So that we can see that in a reading they have the score 70, whereas in writing it is a median score is 69, whereas in mathematics it is 66. Okay, so it seems that they are doing good on average in reading and writing, but a slight performance is not good in the mathematics. Okay, so let's check the results with the help of Moore's median test. So I'm going to apply Moore's median. The response variable is score. The factor is basically our subject. So press OK. So if you can see again, even from the Moore's median test, we are getting the same result, and we can see that the median score is the same as well. Okay, so that means we can say that the students performance in reading and writing are approximately look like equal, but in mathematics they are not doing good compared to reading and writing. Okay, so that is our first hypothesis. Now if I want to perform the second, that is over here it is saying that an educational consultant claimed that on average students receive a respectable score of 70 or more. Okay, so in that particular case, so that means here we have given the target number. Okay, that means our H naught is because 70 or more, so we are going to apply H naught first. Okay, and the alternative is going to be less than 70. Okay, so when we are talking about null and alternative hypothesis point of view, so in that case, if the overall scores follow the normal distribution, then we can apply in that case one sample t-test. If data do not follow the normal distribution, then in that particular case we can apply sign test. So let's check whether the overall performance variable data do follow the normal or not, like over here. Okay, so stats, basic statistics, normality, and in a variable we are sending overall score. So if we can see that again the p-value of the overall score is less than 5%, so that means data do not follow the normal distribution. So that means we have to apply over here the non-parametric test, which is basically the sign test. So how we can do that? We can go to stat non-parametric one sample sign. The variable is overall performance, and the median value is basically they are claiming 70, whereas our alternative is less than. Okay, the H1 is less than. So press OK. So if we are going to see the p-value, that is going to say that reject H naught because p-value is 0.02, which is less than 5%. So we are going to reject H naught, that means accept H1. So that means on average basis, the students are not getting 70 or more marks. It is they are getting less than on average 70 marks. Okay, so the educational claim is wrong. Okay, so in a third hypothesis, they are saying that there is no significant difference in the mean score of the students who have taken the test preparation and those who have not taken the test preparation. Okay, so let's see what kind of variable it is. That is basically the test preparation score. So they have only two levels. One is none, so they didn't take the test preparation. Okay, another one is they have completed the test preparation course. So only two level, both are independent, so we can go for the two sample independent t-test if the overall score is do follow the normal distribution. But as we have seen that the overall performance is not normally distributed, then in that case against the two sample independent t-test we have seen the test is the Mann-Whitney test. So how we can perform Mann-Whitney? We can go to stats, non-parametric, Mann-Whitney, okay, and we can see that if we are want to apply the Mann-Whitney test, we need to rearrange the data. Okay, how we can? That is first sample and second sample. That means we need to create another two column, and we need to write the students who do not prepare the data. We have to sort the data over here, and the students who have completed the score we need to arrange another column. But right now what I am going to do is I am assuming that overall performance do follow the normal, so I am going to apply the parametric test, okay, which is basically the two sample independent t test. Okay, so because we are going to pick both samples are in one column, because overall performance in a separate column, and in a that is going to be, okay, let me do it again. So overall performance is going to be in samples, whereas in sample id we are going to send the test preparation score variable. So in an option I am saying that I am again assuming the variances are equal, otherwise we need to check. So press ok, again press ok. So the p value is less than 5%, we should reject h naught. That means the students who completed the test preparation course and student who didn't completed the test preparation course, they are on average performance is not significantly equal, they are different. As we can see over here, the students who have completed the test preparation score are doing good, as we can see that their average score is greater, their standard deviation is less. Okay, now let's move to the last hypothesis, that in which they are saying that there is no relationship between the gender of the student and corresponding academic performance. So corresponding academic performance, we have created a variable called verdict. Okay, so we are going to check the association between those variables. So as we know that gender is a qualitative variable, as well as verdict is also a qualitative variable, because we are saying that if the students got 40 or more, so we are going to say that the overall performance is acceptable, otherwise it is not acceptable. So this variable is created based on the average score of the overall performance variable point of view. Okay, so what is our h naught, what is our h1? So we know that over here, that means there is no association between gender and the overall performance of the student, or you can say verdict, that is going to be h naught, whereas h1 is there is association. Particular case we can apply the test of chi-square test in order to check whether is there any association between gender and the overall performance. So how we can do that? We can go to stat tables and chi-square test for association. Okay, and we are going to pick row data categorical variable. Okay, so that is row data is basically going to be the gender, whereas in a column we are sending the variable called verdict. Okay, so in statistics I'm using by default, so press ok. So again, if you are going to see the p-value, that is saying because it is greater than 5%, we are going to say except h naught. So that means there is no association between the gender of the student and the performance in the academics. So whether it is a male or female, it is not compulsory that male are doing good or the female are doing not good. So that is basically there is no association between the gender as well as overall performance in the academics. So thank you so much. See you in the next video.